I believe I was saying something in yesterday's video about how I don't take in Mesas as a rule. This one, like the other one, was kind of grandfathered in. This one belongs to a client who's had me do a lot of work on a lot of very nice amps. And he wanted me to fix this up enough for him to sell it in good conscience. For a long time, it's been working fine. The left output stopped working. He swapped the tubes from the right to left. The right kept working, which tells him and me that the left channel is electronically faulty, but the tubes are fine, most likely. He said he looked at the circuit board and saw a resistor that looked not at its best. We will get to that. I'm sure he's right. Let's take this lid off. And before we open it up, let's check the fuses. So we've got a fuse for the right, the B channel, and a fuse for the left, or A channel. This will be 1 amp fast blows. Indeed, that's what this is on the left channel, which is the non-working channel, but that fuse looks fine. Same for the right channel, the B channel. So the fuses are good. And let's just make sure the mains fuse is the correct one. It should be like 6.3 or something. And indeed, it is. Sorry, 6 1/4. So let's turn this over and take the rear cover off and see what we see. Well, this looks like a SimulClass 295. So you've got every section mirrored to itself. This is the channel A, or left, which is problematic. This channel B, or right, which is working correctly. And I immediately see, which is probably the same thing that Brett saw, this resistor here has lost all its stripes. This thing's gotten very hot. This is a 2-watt carbon composite resistor between the screen and plate of this EL34. Each side has one 6L6, which is more conventionally run, and then they have an EL34, which is driving its screen voltage through this resistor from the plate. And you can see it over here working still, or at least not as damaged. These are the screens for the 6L6s, and these are the screens for the EL34s. And there's a couple of other of these carbon composites in here. So it's probably a matter, hopefully, of just changing out some of those carbon composites for a sane choice, metal film, metal oxide, or wire wound. So let me measure what this is supposed to be and see what I've got. I believe it's a 2.7K. Let me check that. The schematic says it's a 2.7K. Let's see what we actually have in here. 2.9K, 2.8K, but it's gotten hot, so that's its measurement when cold. Doesn't mean that this thing actually works. 3K and 2.9K, so they're all within the very wide tolerance of a carbon composite. Let's check the screens on the 6L6s too. 513 ohm, 518, 530, and 518.5. So all that should be working. Let's just check some of these other carbon composites and compare them from channel to channel. This one here, 22.8K. It's compatriate on the other side, which is working. 22.5. These are voltage balance resistors across series capacitors, so these won't measure anything useful in circuit. They're going to measure very, very large. I don't think we're going to have to recap anything. Let's start by seeing if I have a suitable wattage 2.7K, even if it's just a temporary thing to put in here, and then see if this channel comes back to life. Well, I had a whole bunch of half-watt and 1-watt 2.7Ks, but I didn't have any 2 or 3 watts. If I will order some. This is a ridiculous 10-watt ohmite, which will be more than adequate for our purposes, just to see if the only problem was this damaged resistor, which indeed smells terribly. It's just really smoky smelling. So I expect this is very likely going to be the silver bullet, though this is an overqualified bullet for our purposes. So let me turn the amp on, and then I'll take it out of standby and see what kind of signal it might pass, and we'll keep an eye out for any magic smoke or anything. All right, so my light bulb limiter is saying, yeah, that draws a lot of current, but then it settles down to the normal amount that first flares from the heaters of the tubes, having that inrush current. That's all normal. And the fan is on. I'm waiting to see the tubes show some filament action. Yeah, okay. So let's take channel A out of standby. Don't see any magic smoke. Let me turn the volume up for that channel. I am not hearing anything. Well, let me do some more tests. So I traced the voltages, and they all seem fine up here, and they're fine on the output tubes. But V1, the plate at pin 1 was in the normal range, but the plate at pin 6 was like 4 volts, way low. So here are the two plate resistors, 22K and 22K. The one which is attached to pin 1 measures fine, 22K. The one going to pin 6, supposed to be 22K, measures open. So I've got to change out that resistor. Let me do that real fast. Well, it took a little bit, but I've gotten there. We had a voltage drop from the incoming side of this dropping resistor to the other side. And it was greatly just, a huge difference between the working B channel and the not working A channel by about 150 volts. So I first tried the 2 watt 22K ohms on both sides. You can kind of see one here. This is a 1 watt 22K, which is temp 10. I'll put in an actual 3K since we have the real estate available, but that's there for now. So it wasn't the old dropping resistor. And I had to go through and narrow down a few other things, including the little limiting transistor used on the cathode of V1 of each stage, which is kind of like the current limiting. It's exactly like the current limiting circuit in the old SOB, because that transistor can fail. But in this case, it was not that. What it was, and this was kind of a Hail Mary, is I lifted the connection to this filter cap, which is only used for this stage. So on the low voltage side of this resistor was this filter cap. I verified it was not this Zener diode. I verified it was not any other component, which left us with this. So I have lifted this end up in the air off the solder joint, and I temped in this MOD, which is a 40 microfarad versus the 30. So this is a temp. I'll replace that with the exact value that would originally be in there. This is just for troubleshooting. And now with a changed resistor here, a non-bad plate resistor here, because that thing was measuring open, a temporary but very, very good screen resistor here, and this temp 10 MOD, we have signal. So the amp is working, and it's comparable on both channels. And so I'm going to order a few parts. This is going to be about $15, $20 worth of parts, and not very long. I get told when I criticize this brand that I just don't understand complex circuits, and I can't find things, if anything tougher than a Fender. And I'm like, well, that's just your opinion, man. But, I understand what this transistor here does. I understand what this Zener, the 47 volt Zener does, and the other one, I know what a Darlington does. None of this is strange, advanced stuff that I don't recognize. It's just sometimes it's better implemented. So while this older SimulClass is better built than the more recent Strategy 88 that I featured in the other video, there's just no reason for Mesa to still use these giant carbon composites in the power supply, especially here in the screen grids and in the droppers. They always go bad. They just, it's routine. When one comes in and you've got a problem, that's what it usually is. In this case, it was that and a few other things, but this is always top of the list of things to check. Hope you found this interesting, and thanks for watching.